And before I begin this session, I would like to extend my sincere gratitude to the management and the faculty members of Sona Group of Institutions, especially Applied Science Division, for giving me this wonderful opportunity. And actually, for me, it's a moment of pride and honor to get invited to this prestigious group of institutions to be a resource person. And especially special mention is about Dr. Sridhar for continuously contacting me and for believing in me and giving me the required drive to conduct this webinar in sustainable energy. So right now my talk will be completely concentrating on this solar energy. So thank you to the management and the organizing committee for your invitation to be part of this great institution, and I hope the students can benefit something from this lecture in today's lecture. So with this note, as you all know, like in any webinar, that there will be like a question and answer session in the end of the talk. So you can, if you have any queries about or comments to make about any of the content, you are most welcome. You can just put it in the chat box and we will find time to discuss it in the end of the talk, or you can personally email me to my email so that I can respond after that, even the time doesn't permit. So with this small introduction, so as you all know, I'm Dr. Preethy. I'm from University of Technology and Applied Sciences from Sultanate of Oman. So I will begin my webinar. So just wait till I start my presentation. So the theme of today's talk, so welcome all to today's webinar. So the theme of today's talk is that energy for us is like an opportunity. It can transform the lives, it can transform our economies and also our planet. And the change is so drastic that there will be, soon there will be nothing left to burn on Earth but Earth itself. So that is the present state scenario now, that we are already running out of time. So soon there will be nothing left to burn on Earth but the Earth itself. So welcome all to today's webinar on solar energy, its prospects as well as its challenges. So Elon Musk, as you all know, he's a very famous entrepreneur. He once made this comment that our goal is to fundamentally change the way the world uses its energy. We want to change the entire energy infrastructure of the world to zero carbon. I wonder why he made this statement. And I believe it is because of this. Why? Because the future of our children, the future of our planet, it is always in our hands. And that's why energy always matters. So to begin with, what is energy? Energy, as we all know, it is a capacity to do work. For any machine to work, we need any of the various forms of energy. You all are from science background, so you know it very well. And what are the different forms of energy? They can be like chemical energy, heat energy, potential, kinetic, electrical, atomic, to name a few. And then if something is moving, we are having, as we all know, we are having two types of energies, kinetic and potential. And the sum, we call it as the mechanical energy. So then why the energy is important? As we all know, in any country to develop, for the economic growth, we need the energy because that is a prime mover of economic growth of any country. And for the sustenance of any modern economy, it is the vital thing. Why? Because the economic growth is always depending on the energy resources that are affordable, accessible, and as well as environmental friendly. And on the other hand, the industrialization as well as the infrastructure, it always contributes to the economic growth, which in turn requires the energy. So in like simple schematic, we can explain like this. The more you consume the energy, the more you are prone to, you have the industrialization as well as the infrastructure. That means the more you will have the economic growth, which will again in turn will use more energy. So they are interconnected. So based on how the energy is extracted, we are dividing the energy resources, or we already divided the energy resources into two. One, we call it as a non-renewable, and the other one, we call it as renewable. So what is the essential difference? I marked one as in red and the other one is in green. That is the theme. So non-renewable means that is going to be exhausted in a period of time. That means we cannot use it repeatedly. That is going to finish soon. And on the other hand, they can cause the pollution, and also it needs the combustion, because it causes pollution. Why? Because it is requiring the combustion. So, and what are the normal non-renewable resources that you already know? They are coal, petroleum, natural gas, nuclear, to name a few. Whereas on the other hand, renewable energy resources means, what is the difference? They are something which you can use it again and again, or it is available in abundance. And it is the major advantage of renewable energy resources is this, that they are eco-friendly, they are clean, and requires no combustion. And what are those renewable energy resources? They are solar, wind, biomass, tidal, geothermal, and wave. So today's talk, I'm picking only one, that will be solar. And the classification of energy resources are again based on different criteria. That means it is based on age. That means how you are using, how long you have been using. Based on that, we call them as conventional or non-conventional. And based on the availability, that means if it is going to finish soon, we call it as non-renewable. If it is in abundance, we call it as renewable. The more you are using it, we call it as commercial, and the other one we call it as non-commercial. And based on the origin, we call it as fossil fuels and non-fossil fuels. So non-renewable are, till now, they are the conventional, they are the commercial resources for us. And we want to change it to renewable, which is non-conventional or non-commercial, because we are not used to it till now. And the another classification is, we call them as fossil fuels, non-renewable resources. We call it as fossil fuels. And why they are going to finish soon? Because if you take the petroleum, the very common one, in the petroleum, we know that petroleum is actually, it is like a combination. It is a combination of oil and natural gas. Together, we call it as the petroleum. So how you can make that petroleum, how the petroleum is made? Actually, it takes millions of years to form the petroleum. That is why it is called as a fossil fuels. It is formed from the plants or animals that lived in the ocean millions of years ago. That means if you want to make petroleum, how the process will be? That means millions of years ago in the ocean, there were like plants or animals. So with the time, what will happen? They will die and they will be covered under ocean floor with the dirt and the layers of sand. And over the time, as the time progresses, what happens? There will be like more and more sand or the water will be deposited over it. So it gets buried deeper and deeper. So once the remains is going into the earth, what will happen again? Inside the earth, you know, the temperature is very high and also the pressure. So if you are having more temperature and pressure, what will happen? The enormous heat and the pressure will change them into, they will lose its water content and they will be trapped in the rocks in the form of oil and the gas. So they will be having like a carbon content. It will be more like a carbon. So this we call it as, so it takes about billions of years for the petroleum to form. And now you take the next one, it is coal. Again, what is the process? The process is exactly the same, but only difference is where? It is from the origin. That means from where you are starting. In the case of petroleum, you are starting from the plants or animals lived in the ocean. But whereas in the coal, it is different. In the coal, it is formed by the plants or the trees that lived in the land. Okay, so when the plants or trees that was in the land for millions of years ago, what will happen again? The process is exactly the same. They will die. They will be buried in the sand, in the slit or the water, and then it will be covered with more and more sand. And finally, it will be buried deeper and deeper, and the temperature and the pressure will change its form. So depending on its carbon content or how it is, where it is deposited. So if it is more close to the surface of Earth, it will still have some water content. So that one is having less carbon content. So we call them as peat. Now it is buried more deep. With the time, it will go more under the water, more under the land. Then it will change, lose more water, and it becomes more hard. We call it as lignite. Then like that, it is bituminous, subbituminous, and anthracite. So there are like 5 different classifications of coal. depending on its location and depending on its carbon content. So if you are buried more close to the surface of the earth, that is having less carbon content or more water, and that we call it as the peat. And once you go into anthracite, you are losing that water content and it is more having the carbon, and then finally takes into a robust structure, which we call it as the anthracite, which is having around 98% of carbon. And this is what we exactly use for the power plants. This is the anthracite form and the subbituminous form. Then where is the risk now? So this takes about millions of years to form. So once you compare the Industrial Revolution, which started in around 1876, you can see the global energy consumption of the fossil fuels. And what is the trend? It is exponentially increasing. Even after the, like you can see that after the second Industrial Revolution, the change is more drastic. So that if it is going in this way, what is the predicted energy usage for every region? You can see that if you go in this way for after 2020, again the rise is exponential. And also the Asian countries and the Middle East will be the major consumers of energy because of the population. And then what is the risk or what is the problem that we can expect? Very soon we will end up in this problem that we will soon run out of non-renewable energy. That means there will be an energy crisis. So one day we will be running out of this source. So what is the ultimate aim for us? We have to save our energy today to avoid the crisis tomorrow. So to have an idea, if we carry out in this way, that means the way that we are using currently, if you carry out in the same rate, oil deposit can finish in about 51 years, natural gas will finish in 53 years, and the coal to last about 114 years. So this is according to the data of 2016. Okay, so that means you have to again subtract 4 more years. So in that case, that is the one major risk. In addition to that, we are now facing another big challenge. What is that? It is pollution. So according to World Health Organization, 9 out of every 10 people in the planet, they are breathing the polluted air. And it is almost killing 7 million people annually, with low and the middle income countries carrying the highest burden. So if you see the effect of this pollution, that means the major release when you are burning if you are burning something, always there will be a carbon dioxide emission, as you all know. And the more you are having the carbon dioxide, what is the effect on the temperature on the surface of the earth? The temperature is also increasing exponentially. Again, you can see from the Industrial Revolution, the emission of the carbon dioxide is increasing because you are more into industries, and then you are using more vehicles. Everything is more now. And with that one, the temperature is also in the rise. So if the temperature is rising, what we call that? We call that phenomena as global warming. So how you define the global warming? Global warming is the current increase in temperature as well as the surface of the earth as well as the atmosphere, and in both land and the water. So the temperature of the earth is increasing, in simple words. And how much is the increase? It is only 0.8 degree in the last 100 years. That will be our thought. It's only 0.8 degree. But the effect of this 0.8 degree, according to NASA's Goddard Institute, this is the increase in the last 100 years. So mostly you will think that this is such a small number. But the effect of this 0.8 degree in the last 100 years has harmed the earth in so many ways. What are those effects? The first one is desertification. That means many land is converting into desert. That means the plants are not growing anymore. And the next one is that there will be like a increased melting of snow and ice. So what is the risk of that? That means you will have like increased, because of this melting of snow and ice, what you are having stronger hurricanes, cyclones, and then again you will have the rise in the sea levels. So if the sea level is rising, what is the major risk you can expect or anticipate? That means very soon, many places will be under the water. That means the places or the lands which is close to the sea can be underwater very soon. Maybe in the next 100 years, we can anticipate that. So what is the way? We have to save our earth. So the time is high time it is to change into the renewable energy resources. And the foremost reason for this, as we already discussed, is because the fossil fuels are gradually diminishing. We have like a very limited resources, which is going to last in around 50, 60 years. And another major highlight of using the renewable energy resources will be it will have much less negative environmental effect. That because we are not going to burn anything, so that you are having less pollutants or less pollutant emissions, so that you are saving the environment from the global warming or from the greenhouse gases. And it is also actually, it is considered as a very clean energy resources. And another attractive reason is that it is in abundance. It's not going to finish. It is plentiful, large quantity, and also no country is having any ownership like the non-renewable energy resources, so that it will be more cheaper. Then if you now we are dividing the renewable energy resources into major classifications, like major categories. How you are dividing the renewable energy resources? Always from the sources or from your origin. So if the energy of the renewable energy resources are derived directly or indirectly from the sun, then we call that energy resources as like what are the energy resources? They are solar, they are wind, they are wave, and they are biomass. And if the energy is derived from the gravity means the attraction between the earth and the sun, earth and the moon. Because of that also you are extracting the energy, and that energy we call it as the tidal as well as the hydro power. And also, as we already discussed some time before, inside the interior of the earth, the temperature is quite high. You know, like in the center of the earth, the earth is having a radius of around 5,800 kilometers. And in the center of the earth, the temperature comes around 5,000 Kelvin. So in that high temperature, if you can use that heat energy for converting into steam, or like using that heat energy to electricity, we can use that for many applications. And that energy that you are extracting from the interior of the earth, we call it as geothermal. So of this all different sources or different choices, today's talk I'm picking one, because we have to do it for concentrating on one. So that will be on solar. Like Thomas Edison once said that I would always put my money on the sun and the solar energy, and it is such a source of power. So that means he also said that we don't have to wait until oil and coal run out before we tackle that. And I hope I had more years left. So he made this comment maybe 100 years before, but still we took long time to implement it in our lives. So this is the rest of the talk. We will be concentrating only on the solar energy. Solar energy, this is the idea of the talk. So why Thomas Edison, or what prompted him to say this is such a great source of energy? It is just because of the sun. Why? Because the sun is always, as we all know, it is radiating an enormous amount of energy. And you know the amount. It is radiating more energy each day than the world is using in a year. And any of this tiny fraction of the energy, that is, it is traveling about 150 million kilometers, and it takes about more than 8 minutes, just more than 8 minutes to reach to the surface of the earth. And if you do the calculations that according to Stephen Boltzmann law, how much energy you are reaching or how much power you receive from the earth, from that calculation, you can see that every meter square of the earth's atmosphere, it is receiving around 342 watts of energy. And in that one, again, from the atmosphere, some energy will be reflected, some will be absorbed by the atmosphere. So only 57% of the total energy will be hitting on the surface. But so that means it's only 198 in every meter square. So maybe you will think that again, it's a small number. No, why? Because you are averaging over the Earth's surface. Means remember that the radius of the surface of radius of the Earth is around 5,000 kilometers. So when you multiply this number with 4 pi r square, then the amount of energy available on the Earth's surface in joules, that means E will be equal to around 3.9 into 10 raised to 24 joule in a year, and which is about 4,500 times more than the world uses in 2040. So this is the energy that you are receiving in every year. So that will be enough for us to survive even in 2040. So actually solar energy is not at all a new idea. People have been harnessing this energy for quite a long time. That means they have been used for even in 2,700 years before, people were started using the solar energy for drying or for cooking. And in 700 BC, they devised, like they were using the mirrors to focus the lenses to focus the sun's light into get the fires. And again, in the recent time, that means in 1900s, solar collector in this house in California in 1906, where in that house, you could see that they were using the solar collector for heating the water. So in that way, it's not at all a new idea. So if you see the history of the solar energy, that is, it weighs back to about 7th century BC. And the major invention was in 1954, when Daryl Chapman invented the first PV solar cell. And from there is like a solar powered aircraft was invented in 1981. And again, now major breakthroughs are happening in this current era. So now we are coming into the what you call the technical part of the talk, how we can capture the sun's energy. So the sun's energy, you have to use it, means the sun is radiating the energy. You have to find the ways to capture the energy. So we are dividing the techniques into two. One, we call it as a passive solar technologies, and the other one, we call it as active. So what do you mean by the passive solar technology? We start with that. Passive solar technology means you are absorbing the sun's heat or energy, and you are storing it in a very natural manner. That means you are not using any additional equipment for that, for conversion. So that means, for example, in normal houses, if you are having a window facing the sun, you will always feel more heat inside. So what is the reason? The house is facing the sun, so it is absorbing more sunlight and you feel warm. And if your house is made of material which is having low thermal mass, again, you can store more heat. So that's why, and also if you're having like in the winter season, you can see in the houses of Europe, it will be made with material like wood. The reason is that it's a bad conductor. So that means it will store the energy without escaping. So if you are selecting the material with favorable thermal mass, or you are orienting the building to the sun so that you can absorb more, that type of technologies, we call it as passive solar technologies. So normally these days, we are not using it quite often because we are having better ones. So what are the better ones? That is, so this is the example of a passive solar design. So that you are arranging constructing the house so that you are facing more the sun. You are getting the more sunlight. The orientation of your house will be like that. Then in the active solar technologies, what is the difference? You are using some additional equipment. You are using some mechanical as well as electrical equipment to enhance the conversion of the solar energy to heat and the electrical power. And the active solar technologies include that they are solar photovoltaics, solar thermal, as well as solar thermoelectric. So the techniques which we call it as the active solar techniques will be photovoltaics, solar thermal, and solar thermoelectric. So in that, when active solar technologies, we are concentrating our talk from now will be on this one. So what is active solar technologies? Active solar technology is like this. So from the sun, you are getting two types of energies. One is light and the one is heat. And you are using additional equipments to convert that into electricity. That is the meaning of active solar technologies. So you are taking the sun's light, you are converting into electricity. You are taking the heat, you are converting into electricity. So that type of technologies, we call it as active solar technologies.